Okay, now that we got our source ready, let's go ahead and simulate this. So I'll just drop a null here first. Call this out source. Okay. Give this a color again. Purple is fine. And then I'll make another geo. Crowd sim. We could drop a DOP network out here or in there, doesn't matter. Keep it in subs. And then object merge and bring in the crowd source when I find it. There we go. Okay, and then a DOP network here. Plug that into the first port, jump inside. So this is going to be a really simple network, just for starters, right? So all we need is a crowd solver, crowd object. When we find it, there we go. Connect that up. And then in the past you needed a crowd source as well, but now you can just connect it up here to the first context geometry. Now this is a common, whenever something is, you've got some kind of error, you'll see these weird things going on, you know, where all the geometry is kind of crushed up together and you get these weird mistakes. And that's normally because a problem with the names of the clip or the state, right? So if we need a crowd state, okay, connect that up to it tells you what you need going in here. States, transitions that we looked at briefly earlier, source and the object. Okay, so state to this input, and we get that. Now the name of our state is whatever you put here, which is run, initial state. Okay, so let's set that up. So this will be run. Okay, and now we've got an error because it's looking for clips $OS called run, and we don't have any clips called run. We've got clips called run01, run02, and run03. Okay, so we could either do that. If we change this to run01, then we'll put them all into that same animation clip. But we can also have a random distribution of 3. Again, we got that error because it's not finding those clips. Run01, run02, run03. Okay, so if you wanted more control, what you would do is because you know we want to, in our case it's not too important, but if you wanted to add different forces to different agents or different clips, so let's say all of the men who are running with run03, I want to run in this direction, or I want to add some random movement to them, then I can add a force to them. And typically what you would do is have a different state for each one. So I'd have man run01, man run02, man run03, and the same for the woman. And then I can add a force underneath to each one, right? So I can put crowd, sorry. So if you type in pop steer, we're going to use one of these in a moment, but all of these are specifically made for, they're basically pop forces, but they've been adapted a little bit to be used for crowds. And you've got all these different forces that you can use, and you can drop these under, I don't know why that didn't work, pop steer, align, let's say, there we go. So you can drop these under the state, okay? And when you have more than one, you can either put one directly under, so this will only affect this state, or if you merge them together, if you have different states with different clips, if you merge them together, then this will act on all of them, okay? But in our case, we just have the one state with an equal distribution. We do have 6 different clips. We can change so you can see there, I think they're in the same clip, so we can offset the initial clip time. Okay, so they're doing different things. I'll change the offset so they're all a bit more random. You know, change the seed there. And we can add some variance to the speed of the actual clip. Okay, just a little bit, not too much. I mean, if you push it too much and it just doesn't look natural. If you have a motion capture of somebody running at a certain speed and you just double that speed, it's not going to look natural. So I'm just going to put this down to like 5%. Okay. Cool. So I think that's all done there. Now we have already turned on in here. Oh, one more thing we need to do. Oh, well, I'll show you first. If we play this, you see they're all just running in place, right? So that's a couple of reasons. So there's no force, there are no forces pushing them. There should be one, which is the avoidance, but I think because of the scale, yeah, you can see the scale is really small. So if we put the scale up to something bigger, let's just bump it up to 5 and see if they start running. Not even then. Let's try 10. Still not, but yeah, this should get them to run away from each other. I'll put it down to 5, and basically what we need is set this to locomotive. Okay, so that will use the speed of the clip to drive the agents. Okay, and that way we get our feet planting on the floor correctly. And there we go. Okay, so if you focus in on one of these guys, whoops, come in here, step forward, you can see we've got the point moving forward and the agents with their feet planting on the floor nicely. There we go. And if we look from the top, you can see, so they'll initially start running in the direction that we set with the normal, but then other things will take effect. So you can see that they're not following that exactly. It's changing a bit because of the avoidance. Okay, so they're trying to not run into each other. If I turn that off, they should just run straight. Oh, well, more or less, but yeah, it's not a perfect pattern because they have different speeds, right? But I think, yeah, they're all running in a straight line. If I turn that on, they shouldn't run into each other. There we go. So it kind of looks cool already. Great.